Okay, periodic table. In front of you on the screen now is periodic table. It has vast amount of information which is hidden, and you need to know what each item like row or column or any symbol or any number here means. And it will be very convenient for you to learn it, and will be able to use this information very quickly. So just pay attention, guys. And in practice too, you had symbols of elements, and these symbols need to be learned. Please do it because it's like alphabet, and I already told you this. Okay, all known elements, their symbols collected in the periodic table. They are organized in a specific order. They placed in periodic table according to ascending atomic number. The first element here, which is hydrogen, has atomic number 1. Atomic number. The next one has atomic number 2. The third element, lithium, has atomic number 3, then 4, then 5, 6, and so on. Periodic table, as you can see, has 18 columns. They are vertical, and 7 rows horizontal. All elements are divided on metal and non-metal. The majority of existing elements are metals. They are shown here in blue color. Blue color elements. So as you can see, the majority are elements. The majority is metals. I'm sorry. You can notice that here there is a kind of staircase. Yes, and this staircase separates elements on metals and non-metals. Non-metals are shown in yellow. Non-metals. And hydrogen too. Hydrogen is non-metal too. So, to the left of the staircase are metals, except of hydrogen. To the right, non-metals. And I can repeat that hydrogen is non-metal too. Those green elements are metalloids. They are right on the border of metals and non-metals. So they have numbers. 5 is boron, 14 silicon, 32, 33, 51, 52, and so on. And aluminum, it's very interesting about aluminum. Generally, it's metal, and it has all kind of metallic properties. Like we will talk about metallic properties later today, but probably aluminum, how it looks. So it's shiny, it's very light, it conducts heat, electricity, and so on. But so it is metal, but somehow we can tell that aluminum also has metalloids properties. So you can call aluminum in a both way as metal and metalloid too. Please remember that elements that are directly changed to this staircase are metalloids. So we have metals, non-metals, and metalloids. Okay, metals and non-metals are very different by their properties. They're different in color. They're different in having or not having luster. They differ from malleability or density or conductivity. Let's talk about each property. So color. Usually metals don't have a variety of colors. Usually they are silver or gold or like copper, something middle between red and yellow. Some others show characteristic colors, but they always opaque. They have a metallic luster. What does that mean? You can think about coin or jewelry. So they are shiny, or iron can be rusty if it contacts with water or oxygen. So malleability. What does that mean? That means that if you take a piece of metal, and if you hit this piece of metal with a hammer, then the metal will not break into many small pieces. It will it will it will change its shape. I'm sorry. It will change its shape. This property called malleability. Non-metal can don't have any metallic luster, but they can have their specific luster, such luster such as glass or diamonds. They can be in many different states, like be solid or be liquid like bromine, or be gaseous like hydrogen, oxygen, or nitrogen. If metals are very good at conducting cold or heat, electricity, non-metals will not do that. They will not conduct cold or heat or electricity very well, or maybe they don't conduct any of these. And if we compare density of metals and non-metals, we can say that usually metals are heavier than non-metals. Their density bigger than density of non-metals. So non-metals are really heavy. Let's go back to periodic table, to its organization. There is a specific terminology used by describing periodic table, such as column called groups, and horizontal rows called periods. And now, instead of saying column 1, you would say group number 1, this one, group number 1. And instead of saying horizontal rows number, let's say not 1 but 2, you will say period number 2. There are 7 periods in periodic table: 1, 2, 3, 4, 5, 6, and 7. And you can see 7 is not finished, so it has a lot of space for other undiscovered yet elements. And there are 18 groups in periodic table from 1 to 18. Sometimes we will use symbols like 1A or 3A or 3B. What does that mean? That means that if group has number with letter A, this is main groups. Main groups has A, additional A in their names. And these groups with additional B has this group with additional B are transitional groups. And at the bottom of periodic table, there are two rows. One of them is lanthanides, another is actinides, and they have specific name. It's rare earth elements. You will not have a deal with rare earth elements till the end of semester, but you need to know where they are located. Some main groups have specific common names to name them. So instead of saying 1A main group, I will say alkali metals. Instead of saying main group 2A, I would say alkaline earth metals. Group number 7A is halogens, and 8A noble gases. And now later on, if I say alkali metals, I will mean all elements from 1A group. Or if I say halogens, that will mean that I want to talk about 7A group elements. So you need to know symbols. As I mentioned earlier, you need to know a name of these groups, specific common names, and you need to know how column that column are groups, that rows are periods, that there are transitional groups, that in periodic table there are metals, non-metals, and metalloids. Okay? And after this, we will be talking about electron structure of atoms.